Okay. Okay, yes, Ben, go on. Ben, go on and start the prayer.
Hello, good evening, everyone. Let's humble ourselves and we pray. Oh Lord, Father, King of Glory, we want to thank you so much for the gift of life you have given us, for the precious gift of life, Lord Father. We want to thank you for having kept us in this difficult time, for the love, for the protection, for the grace and the mercy you have for us each and every day. We want to pray for our beloved teachers that you may oversee them in whatever they do in their lives. May you bless them. Yeah. May you have mercy on them. Father, Lord God, we want to pray that you may continue to help us understand whatever is taught in the lessons. Oh Lord, Father, King of Glory, I pray that as our beloved teachers teach us, may you touch the veins of our hearts, that our tears of penitence and love will be our bread day and night. And I pray that we may merit heaven one day, and there with thy saints praise you forever. Amen.
Okay, thank you so much, Ben, for the prayer. Now, I think we are good to start. Over to you, Teacher Emma and Teacher Lawrence. You are welcome.
Welcome, sir.
Thank you, Sebo. Am I loud and clear, Mr. Kaziba?
Yes, I'm hearing you. Maybe you can add on a little of your volume.
All right. I want to welcome our students from whichever part of the country you're attending from. We want to do the last bit of polynomials as a section of paper 1, mathematics, that we are doing in line with the S5 content. The last lesson we had last week, it was in line with the concepts of polynomials and the basics that we shared with you candidates, and we hope that you have not been just seated on them. You were also practicing here and there. We want to do the last bits today, and we see ourselves go to the next area. Yes, learning is not stopping. That's why we are even making it sequential, so that we don't lose any bit. We'll still encourage you, those who are always keeping time, to do so, even the next meetings. All right. So back to our document of polynomials. I want to share my document here. Hands up, Ben, you can put the hand down. It is still up. You might think you want to say something. So as regarding the chapter of polynomials, we had moved up to the level of obtaining the remainder. This was our last bit that closed the session we had last week. We looked at this polynomial in a situation where the remainder is given, is not given rather, but the divisor is quadratic to mention. We are told that f of 4 is 7, f of -3 is -14, and we are told to find the remainder when f of x is divided by the quadratic expression x squared minus x minus 12. In such a question, you don't have the polynomial expression, but with the definition from Remainder Theorem, as seen here, someone was able to answer the questions that would follow thereafter. So we are sure that if you have this document, by virtue of that statement, you were able to tell what happens. Maybe to someone who went off earlier, that's why we are doing this recap. By defining the polynomial from remainder theorem as f of x equal the divisor times quotient plus the remainder, we made a substitution of the known items in the question. That was the divisor and the remainder. Can you notice here, why are we substituting the remainder as ax plus b? I'm substituting the remainder as ax plus b, which is actually a linear expression. For one reason, as my co-teacher discussed in the same session last week, the reason is we have general expected immediate remainders depending on the nature or type of divisor at hand at that instant. So the nature of divisor at this point is quadratic. I'm circling only the points of interest. The nature in this question of the divisor is quadratic. The immediate remainder expected is linear. And something linear is that of the form, for example, mx plus c. Something of that nature is expected to be linear. We borrow it from the general equation of a straight line, linear. So though in the solution, we replaced m as a and c as b, but that remains a linear expression if you don't know it. So that's why we substituted for the remainder unknown as not a constant, but a linear expression x plus b. Reason, we had a quadratic divisor. Now, secondly, a key important notice that everyone must have at the back of his mind or her mind is, in this kind of problem, the quadratic expression or divisor is expected to be factorizable. Factorizable, we meant, as we discussed previously, we meant that the ability to find two linear expressions which can be multiplied to get that quadratic divisor is that fact that it's factorizable. And the process you take yourself through here is finding the two factors whose sum, or the two numbers whose sum is -1 and product is -12, and you factorize to reach there. So how do we come up with the two equations to solve? At this point, when you've reached a level, you see that it is factorizable. The process begins there. Remember, the examiner was directive. He said f of 4 is 7. When you feed in f4, the expression should be equal to 7. But the 4 affects the linear expression somewhere because the linear expression is attached to x somewhere. That's how we came up with the two equations we solved. And our remainder at the end of the day was something linear in the form mx plus c or ax plus b, which was 3x minus 5. And basically that was the beauty of the sessions we discussed previously. The concept of not giving you the polynomial, but when you have to play around with the remainder and the divisor is very crucial. I've even made a recap on it. Other examples will come in or through the practice questions you will have encountered. However, this afternoon, we are bound to begin a new subsection called the Factor Theorem. the factor theorem doesn't mean we are changing the topic, but we are embedding into polynomials, but in a special arrangement. How would we come to factor theorem? Factor theorem is reached in a situation when Brenda, before we begin factor theorem, what do you want to say? Brenda?
Teacher Lawrence, I think the audio is off, so she's not hearing us.
Oh.
Maybe Matthias.
Okay.
Matthias, unmute.
Good afternoon, teacher. So can I have the former page, like before the factor theorem heading?
You want to, Matthias
like
wants to do what? To look at it?
Yes,
Just,
like I did.
It's okay.
Okay, teacher.
When you're done, you let me know. Don't delay a lot.
Teacher, I'm done.
Good, thank you. All right, our subsection today is the remainder theorem. The subsection we are focusing on to is remainder theorem, but special way, factor. Now, how has the factor affected the remainder? This is the statement we begin with. Note that a number is only a factor of another if upon division the remainder is 0. Now, we are trying to remind you from the mathematics you knew before, from primary, from Alevel. At least everyone has ever found the factors. You have ever been told to list the factors of a certain number. So the remainder is, you should remember that you used to only call a certain number factor if upon division the remainder realized is 0. Otherwise, it's not a factor. Similarly, we bring it now into our remainder theorem concepts. An expression is considered to be a factor of another only and only if the remainder after division is 0. Now, the earlier stated remainder theorem, the idea we have been sharing from the beginning of the topic, we said that any polynomial is given by the divisor multiplied by the quotient plus the remainder. Divisor multiplied by the quotient plus the remainder. Now, if this divisor is a factor, the expected remainder should be 0. It should not be an integer like a 2, 1, 3, no, 0. It's not even an expression. It is 0, a value 0. Now, what will the expression or equation of this kind become? It will be divisor, if that divisor is a factor, times the quotient plus 0. Plus 0 here. That means the polynomial is directly a product of the divisor times the quotient. This is true, ladies and gentlemen, in the lesson. This is only and only true if and only if the divisor at hand is a factor. Hence the factor theorem. Hence the factor theorem. How are we going to be using it? How are we going to be using it? But in our notes, we are saying this factor theorem as we can see, the divisor and quotient look to be the factors of the polynomial. Reason, when you divide the polynomial with the quotient, you get back at the divisor. This statement is what I want to explain. This is an equation. When the polynomial f of x is divided by the quotient, you will get back at the divisor, which is true on the other hand. The same polynomial can be divided, as we mentioned, the same polynomial can be, when you divide both sides by the divisor, the resultant will be the quotient under factor theorem. Those are the special bulletins that you must take in. You resolve, you must take them in. Now, what will happen? Still, we want to do a background check. What will happen when you know that divisor as a linear expression? Remember, we have just said that the polynomial being equal to the divisor multiplied by the quotient without the remainder attached. This is a factor theorem. This is a factor theorem statement. Reason, the remainder has been set to 0. When the remainder is 0, it means the divisor is a factor of that polynomial. When you divide that, when the divisor is taken through the polynomial, the remainder is 0. Now, let us suppose this divisor is a quantity x minus a. I want us to go back to our details where we began from. So when I want to eliminate, going back to the details before, when I want to eliminate this quotient statement, I'll look for a value of x that makes this divisor 0. Background knowledge, we said you set the divisor to 0. When I set x minus a to 0, x will equal to a. That means when x equal to a is taken through this equation, the quotient will vanish. In other words, the quotient will be hit by 0 and it will be no more. Now, what is special here? When I feed in x as a in the whole equation, this will be a minus a multiplied by the quotient. If we knew it, where there is x, we would feed in a. My interest is someone to notice that this quantity here is 0 times q, which will be 0. Now, previously, under the general remainder theorem expressions, we used to get p of a as the remainder. But now, under factor theorem, the value of x, Infinix Hot 5, you need to next time to put a name. However, you can, I don't know whether his mic is on. He has disappeared. Generally, under factor theorem, we want to say that the value that makes the remainder 0, when it fed into the equation or the polynomial equation, it must be equal to 0. This is a very important idea. This is a very important idea. We'll embed in statements like roots or solutions. Jovet's hand is up. Jovet. Say something.
Jovet, unmute.
Jovet, you will have to type for us to save the time. You'll have to type and we'll look at your argument. Thank you. When she types, I will beg that she Michael presenters, you let me know. P of A is 0, but A is the value of X that makes our remainder 0. Subsequently, let me mention straight away, if the polynomial was equal to 2x, for example, minus 3, multiplied by the quotient, that would mean that P of 3 over 2 is equal to 0 in that polynomial. If at all, only and only if 2x minus 3 is a factor, after all the remainder is not attached. How do we get 3 over 2? We set the divisor 2x minus 3 to 0. 2x will equal to 3. Then x, or upon dividing both sides by 2, x is 3 over 2. X is 3 over 2. You need, Jobet, you need to check your sound. It's Christian. Christian says he's not hearing. All right. Back to the document. The first example in this kind of arrangement. This is the first example. Those asking for the example. We have been giving a general overview of how the factor theorem is used. Now, this is the first example. And I've just emphasized for Jovet's case, let me repeat where we are setting a 0. Oh, for this case, before we do the example, we need to understand. Normally, we have this kind of situation when we do not know this quotient here. And you not knowing the quotient pushes you to eliminate it. Eliminating it, and besides the quotient, there is an expression in X that can help us to do that elimination. So, for me to set 2x minus 3 to 0, I'm looking at the fact that if this 2x minus 3 becomes 0 times something I don't know with the letter Q, the whole statement will be set to 0 to answer that, madam. So another sample statement. In a situation where the polynomial function, let's make it more lively. In a situation where the polynomial function is, say, 2x squared minus a, and they say that x minus 1 is a factor of p of x, find the value of a. So for me to find that a, I need to recall that any polynomial is equal to the divisor times the quotient, all functions of x plus the remainder. But this remainder, the moment you see the word factor, you know that that remainder straight away, you don't need to consult anyone. Remainder is 0. The moment you realize that the divisor is a factor, if the statement has been made, the divisor is a factor, then the remainder is 0. But the divisor is x minus 1. It is multiplying a quotient you don't know. However, you know the polynomial as 2x squared minus a. The polynomial is of degree 2, which we call a quadratic one, polynomial. So, said in this equation, to mention, for me to solve for a, or to remain with the letter a as the only unknown, the unknown q should disappear. It should become 0. it should vanish. How can it vanish? The expression x minus 1 attached to it, I should set it to 0. Set that to get a value of x to feed in such that q disappears. When I set x minus 1 to 0, I'm able to obtain or attain x equal to 1. Now, at this level, when you feed in any value of x, the equation becomes normalized. It holds, it remains correct. So feed in x as 1, 2 into 1 squared minus a is equal to 1 minus 1 multiplied by q of x, or q of x, which is 1. Of course, there is a 0 here. Now, 1 minus 1 is 0. 0 times the quotient substituted with 1, I will still get 0. So I remain with the 2 minus a equal to 0. Therefore, the value of a in this polynomial is equal to 2. I've started with a very simple one, not in the document, but for purposes of illustration of the idea. Christian needs to be helped. His device is not transmitting any sound to him or her. Back to the document. Back to the document. Example 5.
Teacher, I'm not hearing anything.
I don't know whether it's the case, it's the same case to everyone. The other teachers, are you hearing me?
We are getting you loud and clear.
That madam needs to be helped. All right. Our example, beginning this session, it is saying x minus 3 and 2x plus 1 are both factors of the expression f of x as listed below. Determine the values of a and b, and hence solve the equation. So in our solution, we'll begin by remembering that if those are factors, then f of x is divisor times quotient plus the remainder, which is 0. So I can just write that after all I've realized, I'm going to be dealing with the factors. And it is true that my first divisor is x minus 3. X minus 3. That means f of, if a candidate has been following, f of 3 will be 0. That is the value of x you get after setting x minus 3 to 0. You will get x as 3. So when you feed in a 3 here, you get a 0. Similarly, since even the other expression 2x plus 1 is a factor, so similarly, f of negative half is also equal to 0. I've generated the two equations. What we are just waiting for is to feed in the x values into the polynomial to yield the required equations to help us solve for p and q. There's just a slight statement here we need to correct. Everyone should look in. The unknowns are p and q. So our equation here should be, our question should be determine the values of p and q. We should check that. Okay, Mia says something. It's good to ask at that point before I get the two equations we need to solve. Yes, Mia. We can allow Mia to ask.
Teacher Lawrence, I think you are sharing the wrong screen. We are not seeing your board.
All right.
We are still looking at the document. Okay, now it's clear.
Okay, sorry for that. Sorry for that. All right. I think it's easier to have the whole screen. I think those people's hands were about to the screen. They wanted to see. They have lowered them.
It could have been the problem, but it's now okay.
Yeah. Okay. Asaba Brenda. Ashaba Brenda. Ashaba Brenda's hand is up.
I'm not seeing the workers, sir.
Even now?
Yeah.
Oh.
I'm just seeing some students.
No, I think she has a problem with her device. Try to swipe to the left. Your screen must be, swipe your screen to the left.
Okay, I've seen, thank you.
Okay.
Okay, thank you, Brenda. Let's hope we are moving together. Okay, it's okay, it's okay. It's okay. It's okay, Owen. All right. Hope we all agree with the equation we have right now. So we want to proceed to obtain. We want to proceed and obtain the unknowns P and Q. So looking at our function, f of x, when you feed in a 3, so we are going to respect the conditions I've just put down here. I think those minutes are enough. I've given for everyone to brainstorm those statements. F of x is given, so we have concluded that f of 3 is 0 and f of negative a half is 0. Someone might wonder how we get negative a half. We set this factor. We set the 2x plus 1 to 0. 2x will be negative 1. And when you divide both sides by 2, x is negative a half. That's how we settle to that. Meaning, when x has negative a half, is fed into a similar statement like f of x. When you write a similar statement, a polynomial definition like f of x equal to the divisor now as 2x plus 1 multiplied by the quotient. Since it's a factor, the remainder is 0. Even if you don't write it, f of negative a half will give us 0. Because 2x plus 1 is 0, 0 times the cube will give us a 0. So that's how I landed to those two statements. So our function for everyone to follow. I'm going to bring back the question here. We see the function. Our function is 2x to the power 4 minus 5x cubed plus px squared plus 25x plus q. So we know that f of 3 is 0. So in that function, to get the first equation, someone can feed in f of 3. F of 3 will be what? That is 2 into 3 to the power 4 minus 5 into 3 cubed plus p into 3 squared plus 25 into 3 plus q. However, f of 3 is 0. This statement, before I even scroll, I want to keep it there. I'm going to respect this statement here. Let me put it in a red circle. That statement, f of 3 is 0. Where I have f of 3, when I put a 0, I will have an expression this side with the two unknowns, p and q. And then we do the same for the negative half as well. So if someone has been following or is following right now, but as well while trying out, you will agree with me that this is 2 into 81 minus 5 into 27 plus 3 squared, that is 9p, plus 25 times 3, that looks like 75 plus q. Can we compute that one? So that first equation will be what? The 9p plus q will equal to which quantity? What's that constant? You can send us that constant here in the chat box. Be active, 2 into 81 minus 5 into 27 plus 75. Thank you. The first shot is from Ramal Nabatanzi. Thank you. Uzaifa 102, Tazan Junior 102, Lighters, Daphne, Owen, thank you so much. Thank you. So 9p plus q is equal to 102. And that serves as our first equation. You do the same. You do the same in the same polynomial. Also, f of negative half will equal to, you do a substitution. This substitution point is very important. Very important. People who score highly in this paper 1 are those that take care of the algebra. And these are things like a substitution. It's one of the games you must play very well under algebra. That way. Let's compute that one to go to equation 2. In the same line, I want you to remember that f of negative half, as we set it here, box it in red, f of negative half is also 0 to mention. It must be that. Someone is saying it is equal to negative. Let me check.
Yeah, they gave you the figure before transferring it to the other side of the cosines.
Okay. Yeah, people didn't notice that we were transferring. The figure they were getting was still on this side, but I wanted it to be on the left-hand side. It was missing a negative. Okay, let's compute that one for equation 2. This is a 0 as well. That is 2 into 1 out of 2, but to the power 4, it's even, so that will become a positive, minus 5 multiplied by that odd power, that becomes a negative 1 over 8. To be comfortable, you can put those brackets, plus p multiplied by 1 out of 4 minus 25 over 2 plus q. Compute that one. This is 1 over 8 plus 5 over 8 minus 25 over 2. Get for us that fraction. This is P over 4 plus Q. Get for us that fraction. Drop it in the chat box here. 1 over 8 plus 5 over 8 minus 25 over 2. Okay, I see some answers already flowing in. Two participants hand are up. Nyakecho first, say something. Nyakecho, say something.
Teacher.
Yes, please.
I've got 1 out of 4p plus q is equals to 47 divided by 4.
Oh, you are giving us the answer. It's okay. It's okay. You have p, so the resultant expression is p over 4 plus q equal to 47 over 4. This fraction here, its a sign, I think it's a negative. So when you transfer it to this side, to the left-hand side, after it has crossed the equal signs, it becomes positive. So to normalize this, I want us to multiply all through by 4. Those are common things we do in pure maths. Multiply all through by 4, that thing or equation, I think it will be equal to 47 sharp. The 4 clears the quarter on P and it clears the quarter on 47. Students in the room, do you agree with the two equations? Equation 1 is P plus Q, 9P rather, I think. Equation 1 is 9P plus Q equal to negative 102. And then equation 2 is P plus 4Q, which is equal to a 47. We want to be at the same level. Those two equations have been yielded from the comprehension of the fact that those two linear expressions given are both factors of that polynomial. So we are in a position to look for the unknowns P and Q. The unknowns P and Q. Solving these two simultaneously, it's up to you. You have a variety like substitution. Choose between substitution or elimination and the handle. You can multiply the upper one by 4. I can choose 4 as a smaller coefficient. Multiply it in equation 1, you get a 36p plus a 4q equal to 102 times 4. We get negative 408. Then keep the downer one intact. I've made the coefficients of q the same, and they are all positive. That means I'll subtract the two equations. When I subtract them, 36 minus 1p, I get a 35p, giving me negative 408 minus the 47, which is a negative 455. Dividing both sides by 35 by a 35, what's the value of p that you see? It should be, I think, negative 13. That's what we expect. Good. Those who are already there, that's good. That's good. When you solve equation 2, p plus 4q is 47. So negative 13 feeding in equation 2 plus 4q is equal to 47. Therefore, 4q is equal to 47 plus 13, which is a 60. This gives us q as a 60 divided by 4, which is a 15. I've already seen some people there. That's wonderful. Those who have already got them. The question doesn't stop there. However, I'm going to hand over to my co-presenter to solve the equation. But before, what is expected of the learner at the instant you've got P and Q? You're expected to rewrite that polynomial or equation, or it may be an equation, it can be an expression, whichever name it has been given. But the question is not ending there. You're not just getting P and Q. There is a statement that is proceeding. Hence solve the equation f of x equal to 0. Don't wait. Actually, you have not to risk your steps. Rewrite the polynomial immediately. So the moment we reach the last point here, we are going to say, therefore, f of x is going to be, we write the polynomial in the order. Remember, we respect the degrees of the polynomial to be taking the descending order from the highest power of x to the lowest. So the polynomial is 2x to the power 4 minus 5x cubed. So our px squared term is next. So pick p. In the equation or in the question, it's positive p, but what we have got is that p is negative 13. Feed in where p is negative 13, it's a term in x squared, plus 25x plus where there is q, feed in a 15. That becomes the solution to such a problem. Now the examiner goes ahead to say, hence solve. Pick up from, use the ideas. The statement hence, we want to emphasize to all those listening, those who have attended today's lesson, the statement hence, brainstorm your solution from where it started. Apply the ideas you've used already to recall to the next solution. That's what it may mean. I want us to cross to around 5 p.m. when my co-presenter is the one taking us through. Mr. Emma.
Okay, thank you, Mr. Lawrence, for that good work done. That was good of you. Good evening, everyone, since they have not yet heard from me. And okay, so by far, what you have done is to go through the introduction to the factor theorem. First of all, before you continue, let me first solve this. Nyakesho, your hand has been up for a long time. Nyakesho, go ahead and speak.
Sorry, teacher. Sorry, it's just I forgot to lower my hand.
Okay, that's fine. Nevertheless, we can proceed. Beyond that, you have gone through the factor theorem and in reference to the remainder theorem, like you had done it before. And similarly, the same way, you did division back then in primary level. It goes around the same time that a number can only be a factor of another if you divide and you get a zero a zero remainder. It's not like there is no remainder, but the remainder is zero. That's when it becomes a factor. And if the remainder is zero, it means that both the divisor and the quotient have become both factors of the number. If you would like to have a reference information, you could use the number 8 against 4 and 2. If you divide 8 by 4, you get a quotient 2 with no remainder, which makes 4 and 2 the factors of the number 8 in that case. And that is what you have been discussing with the teacher. In this particular example, you have gone through the concept of dividing with when you have been given some factors of an expression, and all you were required to do is to find the unknown coefficients in the polynomial, which you went ahead to find, and you emphasized at the end that you need to write down the polynomial as it should have been. And so you ended up writing it there as it appears. So with the unknowns filled in the polynomial, then you end up with the correct Christian. I wanted to first finish what I was talking about. You can go ahead and present your query. Christian, if you still have that query, you can go ahead and talk about it. But by the time he went, he was telling me telling you that from this, we need to cross to the next part of the question, which is, if I could go to the document myself, the working document is here. Yes, and hence, and he has emphasized the point, when we say hence, we are trying to say that continue from where you have stopped and proceed with the question. So we are saying that hence solve the equation f of x equals to 0. Now, f of x has already been defined up there. F of x has already been defined as the polynomial that we have in question, which you have obtained as 2x to the power 4 minus 5x cubed minus 13x squared plus 25x plus 15. Now that is f of x. So the equation f of x equals to 0 implies that equal to 0. So we actually required to solve that equation. One would wonder, how are we going to solve a quadratic equation? So the beauty with polynomials is that when we are in the know of the factor theorem, which also comes from the remainder theorem, it gives us the power to solve any equation of any degree. And now we are here trying to solve an equation of degree 4. So the only thing that we need to do there is to go back and look at what our equation actually became. Our equation is the equation 2x to the power 4. That is 2x to the power 4 minus 5x cubed minus 5x cubed minus 13x squared, add 25x, add 15, and that one is equal to 0. But good enough, you already know that you have some two factors, okay? Before it became an equation, it was a polynomial first. There are some two factors, 2x plus 1, and the other factor was, if we could go back to the equation, the other factor was x minus 3. So you have 2x minus plus 1 and x plus 3, and the x plus 3 as factors. Now, if we go back to the remainder theorem, okay, not to the remainder theorem, but let's go back to basic division. If you are dividing, numbers, say for example, you are dividing, okay, let me choose a number like 20. you're dividing 20. The factors of 20, you have factors like 2, you have a factor like 5, okay? If these 2 are factors of that number, then it so appears that even their product will be a factor of the same number. So similarly, Matthias, you're back. What is the problem?
Teacher, can we help repeat from where you started from? Like, I'm not getting, I'm really lost.
Repeat from
forming that equation equal to 0. Like, from where actually I didn't get.
It's okay. I'm going to do that. Ankunda, let me hear from you.
Teacher, the second factor is x minus 3.
It is x minus 3. Thank you for that. Okay, now Matthias is saying that how did I come up with this equation? And this is your answer, madam. That our polynomial in the first place was the polynomial f of x. F of x equals to 2x to the 4th power minus 5x cubed minus 13x squared minus 13x squared plus plus 25x plus 15, okay? And now that is our f of x. Now someone is telling us that f of x is equal to 0. What I know, I already know this, okay? So what I'm going to do is to substitute for its value in that very place, okay? So if I substitute for f of x, I have 2x. I have 2x to the power 4 minus 5x to the power 3 minus 13x squared, added 25x, and add 15. And now what is appearing the other side? The other side there is a 0. So I am just substituting. I'm just substituting with the value that has already been given there. So I think that is fine. Going back to the expression I was making here, that if you have 2, you have 5 as factors of the number 20, then the product 2 times 5 will also be a factor of 20. The product 2 times 5 will also be a factor of 20, which is 10. That one will also be a factor of 20. So why am I saying this? I'm trying to say that if we had these 2 factors, 2x plus 1 and x minus 3, then their product also will also be yet another factor. So except that this one is being linear factors, the other one will be a quadratic what? A quadratic factor. A quadratic factor, a product of two linear factors. So this is the point that we are expected to take advantage of. So you have a quadratic factor, go ahead and divide straight away to get the other quadratic factor. Since it is a degree 4, when you divide by quadratic, you'll end up with another quadratic. And I think that is a good background. We can get started. So our polynomial to start with is given as the function f of x equals to, f of x equals to 2 x to the power 4 minus 5 x cubed minus 13x squared plus 25x added to 15. And you are saying that this one has a factor. So which means if it has a factor, then we are going to do long division and expect a 0. a 0 remainder. So what about our factor? The factor is 2x plus 1, 2x plus 1 times x minus 3. 2x plus 1 to 2x minus 3 is a factor. Is a factor. Is a factor. Is a factor. So meaning, go ahead and expand this product to come up with a quadratic factor that we're talking about. If you could expand this, Mr. Kaziba, Mr. Lawrence, help me establish whether my audio is fine. I'm seeing a lot of complaints about my audio.
Teacher Emma, I'm getting you clearly.
Okay,
Audio is
seems
very
the
okay.
seems the issue to start.
This is Teacher Sairo.
Okay, that's good. All right, can we try to establish the quadratic factor we are talking about? I'm saying let's go and expand these two linear factors that are in a product. Expanding here will give us a quadratic factor, 2x squared, 2x squared minus 5x minus 3 as a factor. What does it mean by saying factor? In the remainder theorem, we already said, if I could remind you, that once we divide, we should expect to get what is a remainder, regardless of whether you're using the division of the remainder theorem. This remainder should be 0, or whether you're using the division of the long division form. So go straight to long division, since you have already done this in remainder theorem. Because we're interested in getting the other quadratic factor, which is the quotient, and the quotient can only be got, Tazan, I don't think your expansion is fine. I have negative 5x. Check that negative 2 should be negative 5. Okay, so can we start long division and come up with that factor that we expect? Let me first expand my working space. All right, so go ahead and do long division with that. Write your divisor somewhere here. That is 2x squared minus 5x minus 3. And you are dividing the polynomial. You're dividing the polynomial we had originally as 2x to the 4th power minus 5x to the 3rd power, again minus 13x to the 2nd power, added to 25x, added 25x, and then to 15. All right, so can we start the division here, and we establish what our quotient will be. The quotient will be the other, like Teacher Lawrence has explained, that if what you are dividing with is a factor, then your quotient will also be yet another factor. Someone is saying, I am confused. Where are you getting 2 and 5? Where am I getting 2 and 5? I'm sure he's talking about this 2. This is, okay, someone using ITEL piece 37, please check what happens when you expand these two brackets, expand that product. I'm suspecting I'm talking to people who are, yes, okay. So can we start now the expansion process, the division process? Emma, that people want me to expand these brackets myself. Okay, let me do that. You see, what we have there is actually 2x into x minus 3 plus 1 into another x minus 3. Seems we should expand it. That gives us 2x squared minus 6x plus x minus 3. Last time I checked, negative 6 plus 1 gives you a negative 5. So it's not negative. That is 2x squared minus 5x. I think now we are comfortable. having done it that way. So that is where I'm getting that divisor. It's good to see that when you're working with people, they are also doing something, regardless of whether they are getting the wrong answer. You have something to correct them. Okay, so can we start division? The other time we agreed that we need to be dividing. They are running chronologically from the highest to the lowest. Leading term here is 2x to the fourth power. Leading term the other side is 2x to the second power. And that gives you, as you divide, what do you get? In our side work here, you have 2x to the fourth power, dividing 2x squared. Your result should be x squared. I'm glad someone has already given me the quotient. That is good progress, but let's proceed slowly. That is 2x to the fourth power throughout the whole divisor, minus 5x cubed, minus 5x cubed, minus 3x squared, okay? Minus 3x squared. So once we do the subtraction, we agreed the other time that when you are subtracting here, do not forget that you are subtracting by a polynomial. So if you are subtracting a polynomial, you expect to have brackets there. That gives us 0 in the first two places and a negative 10 in the other third place. Carry the weighting terms and bring them here. That is plus 25x and added to 15. Leading term divided by negative positive 2 on your side work here. The leading term is a negative 10. Leading term is a negative 10. Okay, negative 10 x squared, and you are dividing with another leading term, which is 2x squared. Okay, I don't think the remainder is 5x plus. Yes, someone's asserting it here. Division here gives me a negative 5. Okay, back to the divisor, that's negative 10x squared, that one. Negative and a negative will give you a positive 25 x and a positive 15. Okay, since it all looks the same, a subtraction on the outside will give me a 0 for everything. So will give me a 0 for everything, and that one confirms what we said above, that once we are dividing with what we know as a factor, then we already know the remainder will be what? A 0. So meaning our polynomial f of x, instead of writing the long statement, can be written as the divisor, which is 2x squared minus 5x minus 3 times the quotient. The quotient has turned out to be x squared minus 5. We would have added the remainder, but the remainder is what? Is 0. Adding a 0 is as good as adding nothing. Okay? So if we are asserting that this function should be 0, now we are reaching the point of solving. So if we are solving the equation f of x equal to 0, okay, we are actually solving this one equated to 0. In other words, they were telling us to solve the equation by method of what? Of factorization. So we have some 2 factors, but even the first factor already has some 2 factors, which were 2x plus 1. Remember them? We should not forget those ones. 2x plus 1 and x minus 3. Okay. Now we are multiplying them with another x squared minus 5. And that is the total f of x. And we are saying that this one is equal to 0. You have done this since near 2. whenever you're multiplying numbers and the result is 0, the suspect is one of them being a 0. So you either have 2x, Adrian, go ahead. Adrian, go ahead. Either have 2x plus 1 equal to 0. Adrian, I've given you permission to talk, which gives you the first root as x equals to -1/2. I don't think he can get through. Or you could be having the second factor, x minus 3 equivalent to 0, which also would give x equals to 3, or alternatively, the other factor. Or alternatively, you have the factor x squared minus 5. X squared minus 5 equivalent to 0. You must begin here. X squared is equal to 5 has 2 solutions. It is a quadratic equation. Expect 2 equations, two solutions, which are the positive value and the negative value. There are 2 roots, the square, the positive and the negative. Square function is a symmetrical function. It's an even function. So we end up with those 2 solutions plus the other 2 to give us a total of 4, which concurs with the fact that a degree 4 equation, we must expect 4 solutions. Okay, so that was it. Such a question can combine those facts that we have discussed. The concept of the remainder theorem, which drives you to the concept of the factor theorem, and lastly, heads you to the concept of solving higher order questions. There is another way of solving higher order questions like these ones, but it is easier when you're using the concept of polynomials. I don't know whether this man still has his question, but he failed to get through. Someone help him and see whether we can help him. But basically, that is it. That is what we are you required of. That was required of you, teacher. Please. Okay. Motongi, go ahead. No Motongi getting anything from you.
I'm asking if you have a question.
If you have a question, go ahead and ask.
I wanted to see the question of this number that you have.
Oh, okay, that's fine. Question is there. The question that we are looking at started from here. Teacher Lawrence started by determining the values P and Q, okay? And I've concluded it by the hence part of it, solving the equation f of x equals to 0. So it started with the factor theorem, and then we have concluded with the same. The first part of the question was the other side was with the teacher Lawrence. Was with teacher Lawrence. Okay, so I think we can proceed and see where to go. That one was your question there. He managed to use the concept of A and B, sorry, x minus 3 and 2x plus 1 being factors. He got the values of P and Q. My task was to continue with the hence part of it, which required me to solve for f of x equals to 0, solving that equation. Okay, I think that one has been good enough. Namiro, as I cross to the next question. Namiro, go ahead. Amir, I'm listening. Okay, let's look at the other question there, which says that expression is divisible by x minus 1, but gets a remainder of 10 when divided by x plus 1. Moheka?
Excuse me, sir. Just was requesting to spread the previous page for some little time.
Oh, to display it.
Yeah, some little time.
Okay, that's fine. There you are. There you are.
Down, yeah, that's it.
Okay. Yes. Let me just use this other space here for matters of time saving. Yes, this other question tells us that we have this particular polynomial, which also has some unknowns in it, and we are required to show that we can solve for the values of a and b. They have told us that x minus 1 is a factor and the x plus 1 is not a factor. Why am I saying it's not a factor? Because there is a remainder, okay? There is a remainder of 10 when I divide by, Moheka, you tell me when you are done. I want to expand this for others to see. Okay, there is a remainder of 10 when we have divided by x plus 1. Sing.
So I'm done.
Okay, good. Sing, what happened? All right, let's proceed to the next question. Yes, we have a divisor, x minus 1 as a factor, is divisible, okay? Learn that word, divisible. Divisible means that whatever they have given you is a factor, okay? Is a factor. So by saying that it is divisible by x minus 1, they are trying to tell us that x minus 1 is a factor of the expression. And if x minus 1 is a factor of the expression, it means that once we divide by x minus 1, we should expect a what? A zero remainder. Are we together? So our polynomial, 3x, remember from the beginning, remember we have agreed that the polynomial 3x cubed plus 2x squared minus bx added to a. Any polynomial can always be written as the divisor of the divisor times the quotient, okay? Times the quotient plus the remainder. So we are saying that at this moment, we have a divisor x minus 1, which means that our remainder will be 0, okay? So if we go back to the remainder theorem, what it told us, the remainder theorem also told us that when we are dividing by x minus a, I will not get tired of reminding you.
Teacher Emma?
Yes, please.
I'm inquiring whether it is possible to expand a bit the question.
Oh, okay, that's let me do that. Okay. I think that is enough. Visible enough, eh?
Yes, it is better now. Thank you.
You're welcome. Okay, I was saying that as a reminder to the remainder theorem, we agreed that when we are dividing by an expression, a linear one, x minus a, then that implies that the remainder will be p of a, okay? If we are dividing a polynomial p of x, a polynomial p of x by a divisor x minus a, then we got the remainder as p of a. So this time we are dividing by x minus 1 and the remainder is 0. It means, so x minus 1 being a factor, okay? X minus 1 being a factor implies that p of 1 is equal to 0. It implies that p of 1 is equal to what? To 0. So which means when we substitute a 1 in the polynomial p of x, this is the one I'm calling my p of x, I should be able to obtain a 0. Go ahead and substitute. Go ahead and substitute. It means that 3 times of 1, 3 times of 1 squared, that is cubed, sorry. 3 times of 1 cubed minus, that is plus 2 times of 1. It is encouraging to see answers already. Thank you, Javette. Minus b times of 1 plus a. That one should give me what? A 0. So which directly implies that I have a 3 and a 2 totaling 5 less by b by a should give me a 0, which also implies that one, I can call it my equation 1, or you can go ahead and say that a minus b is equal to 5. Call that one equation, which you're going to solve. Let's look for the other equation. When we are solving by x minus 1, is this one a factor? Sorry, x plus 1. X plus 1. X plus 1 is not a factor. Why? Because there is a remainder. There is something mentioned about a remainder. So if there is a remainder, then it means that that one is not a factor. Instead, but still it can have some implication. X plus 1 gives a remainder of 10, okay? But what does the remainder mean in the remainder theory? This statement means that p of negative 1, I see the negative 1. The negative 1 is coming from, you see, plus 1 is minus negative 1. Or better yet, we can go the way we went by saying that get that thing and equate it to 0 and get the corresponding value of what? Of x. You get x as negative 1, okay? All right, so that's why I'm choosing my a as negative 1. P of negative 1 is supposed to be the remainder, and that one is given as what? In the question, it is given as 10. Substitute negative 1 in the polynomial. Plus 2 times of negative 1 square minus b times of negative 1. Are we together? Plus a. That one should give you what? Should give you a 0. A 10 the other side. Should give you a 10. So that one gives us a negative 3. The cubic function is odd. Cube a negative and you get another negative. So that is negative 3. Negative 3 plus the other one is even, that is 2. Negative plus b, and then plus a. Plus a should give you what? Should give you 10. Meaning that a added to b should give you something close to what? To 11. Okay? This is yet another equation. Let me first attend to these people with their hands up, starting with Ramla. As I pose it there, Ramla.
Sir, on the first equation, I'm seeing the 5 is supposed to be a negative.
What about the B? Okay, thank you. Thank you for that correction. That's correct. Thank you. Then lighters, someone. If you have the same query, I've answered it once, so you can lower. Lighters, go ahead. She's not here. Matthias. Okay, lighters, you are here. Lighters, go. Matthias, speak.
Teacher, so my query is, why are we equating the P -1 to 10? Yet
we are doing not what?
Like the P bracket -1, we're equating it to 10. Why?
Okay. We are equating it to 10 because of the statement underlined in red. Seeing that?
But I thought...
First, wait, hold. Come here and we read the remainder theorem. The remainder theorem told us, if I could take you back here, that if we are dividing, yes, it is here. If we are dividing by a linear divisor, that worker which is highlighted there. If we are dividing by a linear divisor, then the remainder that we shall get will be P of what? P of A. Remember, the format of the linear divisor we're dividing with is x minus A altogether.
Yes.
So that's the reason why I come to this. I have x plus 1. I check on this left side worker here. I have x plus 1 as my divisor. I modify it to write as x minus A, okay? Because that is my format. So if I have x and x minus and the minus, the A matches with what? With a -1. Are you seeing that?
Yes.
So when I know that my remainder is P of A, it means that my remainder will be P of -1, okay? And its numerical value has been given as what? As 10.
But teacher, okay, yes, I get it now.
Okay, that's good. I think that's all. There's no other query. All right. So we can proceed. The people who have tried to solve these equations, they are telling me that they are getting the value of A as 3. If you have not tried, that break was for you to solve. They are telling me that the value of A is 3 and the value of B is 8. I want to agree with them, and you should find ways of agreeing with us. Hilda, come on, Kasirie, Ramla, thank you. That's good work you're doing. Value of A, value of B, they are stated there. So the question required us, sorry for that, required us to find the values of A and B. It was as simple as that. And I think we have fulfilled the task very well. We have got ourselves the value of A and the value of B. Okay, I think everyone else is giving in their answers. That's very good. Seems we have correct ones. I'll give just one more away from the document, and then we shall proceed. I'll write it here, saying that show. No, let me use a better color. Show that 3x minus 1 is a factor of the polynomial. The factor of the polynomial g of x equals the factor of the polynomial g of x equals to 6x cubed. No, this is okay. Yes, please.
Teacher Henry's hand is up.
Oh. Yes, please. Teacher Henry. Is he really with us?
You can type as we wait for him to respond. Mr. Kaziba. Mr. Kaziba, you can unmute Teacher Henry.
I don't think he's near his device.
Okay, teacher. Okay.
Okay.
Thank you very much.
Oh.
Teacher Emma, thank you very much, Teacher Lawrence. I'm sorry, I went off and lost my powers. Thank you very much. I couldn't unmute. I wanted to request for just a minute, as you can be putting your work, and allow me to communicate to these students. I want to request them to register. Just give them 2 minutes to register so that everybody gets off your a little bit and register. So I'm going to send the link once again. I've been sending it, but let me send it once again so that you first register, then Teacher Emma will continue. I thank you very much, teacher.
You're most welcome. Okay. Am I good to go? The link has come in there in the chat.
We advise all of you to go and register. Just click and do the needful. You come back here. It helps us to prepare for you very well, knowing how big numbers are in this class of math, so that we prepare adequately. Please do the registration. As Anna possibly asks us a question. Anna has a question.
Anna, go ahead.
Okay, teacher. Okay, teacher. Many numbers over 100, like in this meeting, might work.
I don't think I can get your question. Your audio is poor. I don't know if Mr. Kaziwa has got it, but I've failed.
You would possibly type.
Yeah.
Teacher, you hear me?
We are hearing you, but you cannot constructively get your whole question. Eh? There is a lot of breakage. So just compose your question and put it in the chat. Someone will respond to it. Okay, now I think we can set off with this. We want to look at the very last concept, but after this. So this is a cubic equation. You could do it in a number of ways. But the easiest one would be this one that has, it is guided factorization.
Teacher Emma?
Yeah. Yes, please.
Can you help us expand a bit?
You mean, oh, my screen is not.
The question.
Is that good enough?
Very excellent. Thank you.
Okay. Okay. I was still saying that one way we could solve this is through what they have guided us through, factorization. The other way, you could try to feed in a number of values, see which gives you, it is only a root if you substitute and get a 0. But this one goes through the process of factorization. They are guiding you through the process, and that is the way you're going to take. So they give us one factor, and the next thing they tell us is to find the other factors. Now, if it is a cubic polynomial, it can only have 3 factors. A quadratic polynomial had only 2 factors. So a polynomial of degree n can only have n linear factors and thus n roots as we solve. So as we are solving that equation, we shall end up with, we shall expect to end up with 3 roots of that equation. So if we can start off from there, they're telling us that 3x minus 1 is a factor. So this one is a given factor. What does it imply to have it as a factor? It means that when we divide the polynomial with the given expression, then we should expect to have 0 remainder. So what you're going to do is to go and perform wrong division upon this. Okay, let me just make a remark of what I'm saying. It means that dividing, I think someone who cannot clearly see what I'm writing, you may be holding your phone in a portrait position. Try to put it in landscape. When I expand the way you want me to, things will become too big for me. Okay, dividing by 3x minus 1 gives a 0, gives a remainder as 0. So we should expect that when we divide, we should get a 0, meaning that the quotient is another factor. Is another factor. Okay, so that is all we are going to do. So get our polynomial and divide by 3x minus 1. Our polynomial, our divisor is 3x minus 1. Our polynomial is 6x to the power 3. Added to x squared. Added to x squared. Raised by 19x. And then added to 6. Added to 6. So when we divide by 3x minus 1, we should expect a 0 remainder. Let me use okay, this. So the leading terms are 6x cubed and 3x. Divide those ones. What should we end up with? Something similar to 2x, similar to 2x squared. That will multiply the whole divisor to give you 6x cubed minus 2x squared. not forgetting the guidelines we gave the other time, that if there is any power missing, create it with 0 coefficients. And that will give you 3x squared, 3x squared. Wow. Thank you, Francis. Thank you very much. Thank you. Others could try to do the same, but don't rush. The leading term is 3x squared. The leading term is 3x. Division gives you x and 3x. That is 3x squared. X and -1. That is -x. The subtraction there, I've said time and again that if you are subtracting a polynomial, brackets will be very important for your safety. That is -18x at last, and carry the weighting term the other side, which is the constant 6. Leading term -18x, leading term 3, division -6. -6 gives back -18x and positive 6 here. -6 times 1 negative will give you subtraction thereof will give you everything vanishing, okay? Should you not end up with a remainder here, and it was claimed that this one is a quotient, there are two possibilities. I mean, was a factor. There are two possibilities. Either you are doing the wrong thing, okay, the correct thing in the wrong way, or the question was set correctly but with the wrong values. So we don't set wrong questions. So what you do, you try to trace the error. Don't continue even after seeing that the remainder here is what? Is non-zero. So it means that our polynomial has got new shape. The polynomial g of x has obtained new shape. Remember, Mr. Lawrence has been here explaining that in this case, our polynomial will be written as the divisor. What is your divisor this time? 3x minus 1 times the quotient. He said that the polynomial will be written as the divisor times the quotient, okay? Times the quotient. So that one is what we are going to do. That is divisor is 3x minus 1. The quotient is what you have up there as 2x squared plus x minus 6. Other factors are 2x minus 3 and x plus 2. Okay, that's very good. People are doing some work. So what we are going to do is to factorize that other. So if I'm to answer the question was, let's go back to the question. First of all, the first part of the question is show that this one is a factor of the polynomial. How do we show? We have shown by this statement, showing you what you needed to do is to give a remainder as 0. So how did you get a remainder as 0? You went through long division and you got the remainder as 0. Your conclusion would be, since the remainder is 0 after long division, okay, therefore what I have divided with, which is 3x minus 1, is a factor of what I was dividing, which is the polynomial g of x. That's where answer to question 1 stops. So what I am already starting here is question number 2, finding the other factors, okay? Finding all other factors. And we are saying that I already have one factor here. The other factors are embedded within the quotient there. So extract them by factorizing that quotient. So that I hope I've picked up people who are wondering what we are doing. 3x minus 1 as one of the factors. And the other factors, if you do factorization of a quadratic here, I am seeing a lot of things here. But, okay, the factors of -12, which add up to +1, are not -4 and +3. they are -3 and +4. So that will give us 2x squared. Okay, let me just write. People already have what to do. 2x plus 3 into x minus 2. It's not the other way around. It's not 2x minus 3 into x plus 2. I think that is the other way around. Sorry. I was trying to, that is 2x minus 3 into x plus 2. Okay, thank you. Okay, that is 4x and the -3 and +4 will give you that. What we have done, we have just looked at the factors of the product 2 and -6, which is -12, and the factors of -12, which gives you a sum of +1. And yes, Jovia, yes. And we came up with this. So the other factors, yes, Namira.
Sir, I've not got you here where you've got the other factors.
The other factors?
Yeah, how have you got them?
Okay, do you understand the first statement here?
Where?
This?
Yeah.
Okay, if you do understand, if you do understand that, then what I am doing here is a factorization, quadratic factorization of this, of that other quotient there. Let me take you through, don't worry. The other factors will be, first of all, our polynomial, we agree, can be written as that. And if it can be written as that, then the only thing we need to do here is to, this one is already as simple as it can be. Why? Because it has already been given as a factor, okay? So we need to just guard it and look for the others. The others will be the factors of this expression, okay? The factors of that expression there. So you know how to factorize a quadratic, okay? Is it quadratic in the first place? It is quadratic because it is of degree 2, okay? It's not a quadratic equation. I am trying to avoid the word equation here. This is what we call a quadratic equation. Look at a quadratic equation. This is what we call a quadratic equation. Me, I'm talking about this one, a quadratic expression. Are you together? Yeah?
Yeah.
You must learn the difference between those two. So I am not necessarily equating it to 0. I will in the next part of the question. So what we are looking at the factors of 2 and -6. Those are the product of 2 and -6 is -12. Factors of -12 that have a difference of 1, a 3, and a 4. When I add these two, the difference, I'm talking about the difference because one is negative, -6. Common factor, factorized by grouping. I think you can continue from there.
I've got you, thanks.
Okay. X minus 3 into x plus 2. Okay. So those are the other factors. So the factors that this man is asking are the ones that we see underlined there. This one and that one. Those are the other factors of the expression. Then the third part of the question, hence solve the equation g of x equal to 0. Now, remember this g of x also has the original name. The original name was as what? Remember that g of x is the polynomial originally given as 6x cubed plus x squared minus 19x plus 6. Now they are telling you that it is equal to 0. But remember, this one is the one we have just factorized. Okay? It's the one we have just factorized. Okay. Wanted more space. It's the one we have just factorized to give the factors we have above there. 3x minus 1 times 2x minus 3, okay, times x plus 2. And now it is the one we are equating to what? To 0. Are we together? So if you have these numbers as products and they are equaling to 0, just get any one of them equate randomly to 0. So you either have 3x minus 1 equivalent to 0, giving you the value of x as a third. You have 2x minus 3 equivalent to 0, giving the value of x as what? 3 by 2. Or the other value, x plus 2 should be 0, giving your value of x as what? As negative 2. So these ones are the roots. Now, yes, these are roots or solutions. These ones are factors, okay? So roots, solutions, those ones belong to an equation. Factors are factors of an expression. Someone who was trying to confuse the two, okay? So if someone wanted you to give only the factors, there would not be any need to give these ones. I'm only giving these values because I am solving an equation. Must get the difference. And some people give answers interchangeably. And yes, stress in anyondo, that expression there. Okay, except that your thing, instead of being x plus 2, you have made it 3x plus 6. But those ones would be, that would be the statement of factors. The factors are 2x minus 3 and x plus 2. Then the roots are the ones you are seeing there. Roots are values. Factors are also other expressions. Lawrence, do you have any addition to this before?
Yes, sir. Unfortunately, these people don't want to reach the time we close. Some of them don't close with us, which is not good. They miss out the important bits. I pray that those who are hearing me, you stay on till we have a closing prayer. It's very important you get our conclusive statements. Now, Mr. M, I want to briefly to mention that you show us the polynomial where I handed you over to. Now, I want the candidates listening to us to see that polynomial that we started with was a polynomial of degree 4. And that's why when teacher Emma scrolls back to the solutions he got, after mentioning the degree, I want us to see the solutions we got with the teacher Emma. We got x equal to negative half, x equal to 3. Then there are two answers there, positive root 5 and negative root 5. So to mention to someone, to add a voice, I want everyone to observe that these are 4 roots. They are 4 roots corresponding. I've used the word corresponding. They are 4 roots corresponding to the degree of the polynomial we have solved. Now, the very example the teacher has just concluded was a polynomial of degree 3. 6x cubed was the first term. It was a polynomial of degree 3. That's why, the reason as to why I'm making this conclusive statement. That's why the teacher is giving us x as a third, 3 over 2, and negative 2, which are 3 roots or solutions corresponding to the degree of the polynomial, which was degree 3. Why have I said this? It's because when we are doing the paper, some of us The moment you notice that you can get x as a third, you think you have solved the whole polynomial. Always put into consideration at the back of your mind that the degree projects to me how many solutions or roots I should expect. We have 1 minute. As we conclude, I also, unless otherwise, if Mr. Emma, you agree with me, I will give one short one and we pray. It is a very short one.
That's fine.
It's a very short one to trigger the people's minds. I've shared my screen, hopefully. A polynomial is divided by that quadratic expression. The remainder is 2x plus 5. We found the remainder. We have used the factor theorem. Now, what if you're given the divisor and the remainder? And they say find the remainder when the polynomial px, p of x, is divided by x minus 9, bx plus 2. In just a minute or 2 minutes, we can give these people a chance to try it. As we prepare to wind up. Please don't go off as we make these conclusive statements. They are very important. We are winding up this section. We may come back to do something very little if we are true, but we have made it all. We have given you the whole of polynomials, the important details to mention.
Someone who wants to try, put up their hand, then you. Or it's just going to be giving answers in the chat.
I think they will, if they have copied it, it will be fine for them to maybe display them later in the chat. Or but anyway, the fundamental concept.
Vivian seems to be saying something.
She has shut down.
She's on.
Okay, Vivian. Vivian, tell us.
I just wanted to pray.
Oh, not yet.
Vivian, you have taken that in Jesus' name. You will pray. When we say that the polynomial is the divisor times the quotient plus the remainder, we don't know the polynomial. We know the divisor as x squared minus 7x minus 18. We have the quotient, but the remainder is 2x plus 5. And to everyone who has been following our discussion of the topic, you will agree with me. That given that the divisor is quadratic, it is true that the remainder is 2x plus 5, which I can give a title to be linear, to mention. The remainder is linear because the divisor is quadratic. So if part A, the divisor is linear and part B is linear, the immediate remainders we expect will be constants. They will be constants. For example, the crucial statement I want to make before I leave people to complete this, someone must check whether that quadratic divisor is factorizable. And you will agree with me that when you factorize it, you get x minus 9 with x plus 2 as the factors of that expression, which has been given as the remainder. Sorry, as the divisor to mention. So now basing on the fact that Mr. M has been mentioning that the remainder is P of A in a situation where the divisor is x minus A. That means the remainder for part A will be P of the value of x that makes x minus 9 is 0, which is 9. Part B, the remainder will be P of negative 2. After you making x plus 2 look like x minus a, or setting x plus 2 to 0. But my keen interest should be P of 9 is got by substituting in 9 in this equation. The equation boxed in that new color, or what you call purple. When you feed in 9 in that equation, you'll get a 0 in the brackets that are red. It will be 0 times q, which is 0. Then 2 into 9 plus 5, giving us 18 plus 5. Hence the remainder being, I think, 23. Then p as negative 2. You will have 2 into negative 2 plus 5, which is a 1. 5 minus 4. I wanted us to have a short, or to have this kind of problem when you're given the divisor and the remainder, but you don't have a polynomial expression. Many other cases can emerge, dear students, but it all depends on how you how you digested the introduction bit of it. If you've not got the document, you should check in any of your WhatsApp group. You'll get feedback. Some people are saying they have not been able to register. All that will be sorted. Right now, as I leave this solution here, if anyone to see, if we don't have a hand, I will hand over to our host, either Mr. Ronald or Mr. Kaziba, to take us to the climax.
Okay, thank you so much, Teacher Lawrence and Teacher Emma, for taking us through the mathematics. I think now everyone is well contented with the remainder theorem. We are going to be providing more numbers for your revision purposes, and we shall be uploading them on the Padlet. I want to remind the students that tomorrow we are launching the entrepreneurship lesson at 2. So tomorrow we shall have our entrepreneurship lesson. So try to inform your friends that tomorrow we shall have the entrepreneurship, and also we shall have the economics lesson. Economics lesson will come in at 4, and then the entrepreneurship lesson will come in at 2. For other subjects, we are working tirelessly to see that we have biology, chemistry, and physics also come on board. So you are going to wait on patiently, but we shall be launching them as soon as possible. However, we shall be providing notes and other reading materials for those subjects that we have not yet had lessons for them. So that is what we shall have for this week, and follow that timetable. Look at the timetable. Those are the lessons that we shall be having, and we shall always be communicating through our different channels, the WhatsApp mainly, and also other channels. For your work now, like for the work we are going to have today about the remainder theorem, the questions, please submit your work in the hand-in Padlet, and the teachers are going to be there to guide you. Teachers are going to respond to your solutions, and they will be commenting accordingly. So that's what I wanted. I want to thank the Teacher Lawrence, Teacher Emma, Teacher Cyril, Ronald, Teacher Henry, and everyone who has been on the call. Thank you so much. Then I want to remind you that there is a registration link that was put in the chat. Let's register, because we want to make a tally to find out how many of you are doing a certain subject, such that at least we can get sure that if at all we bring this subject on board, we shall have students attend to those subjects. So that's why we want you to have that link, register, and also such that we can be able to know the numbers. Then also I want to remind you that we shall be having a mathematics seminar over this weekend. I want to let you know that we want to have as many presenters as possible. So in case you get the questions, select a question that you'd like to do. Afterwards, go on and do it. Send us the solutions, and then you go on and make a PowerPoint. Then on Thursday, you get ready to attend the presenters meeting. Yes, Ronald.
Okay, thank you, Mr. Kaziva. Are you hearing me?
Yes, you are loud and clear.
Okay, I want to thank the teachers, our presenters today, and please, dear students, can we give them flowers? Do you know where to find the flowers? Do you know where to find the flowers? Please give the teachers flowers. Are you seeing the flowers? I'm not seeing the flowers. Okay, just a few of you are finding the flowers. Okay, now you will discover that our sessions are not only mathematics, but they're also technology driven. We want you to be as good as our teachers. And I hope your teachers told you that we were their teachers. So we are here to carry on the mantle so that you become now the teachers in future. Mr. Kaziva has talked about the seminar. We have enrolled a 1,000 participant room. So no one of you should miss out. Last time, we want to apologize. We had a 300 participant room, which filled quickly, but now we have a 1,000 participant room because you are going to invite all your friends. Let's make history and let us discuss passionately. So on 9th, I think Mr. Kaziva at 2 p.m., Thursday at 2 p.m., the discussants are convening so that we prepare you to discuss better. And we want to bring even the big shots in the Ministry of Education to listen to you speak, to listen to you calculate mathematics, but also to showcase that learning is possible even in these difficult times. We've also mentioned that for the subjects, the subjects we didn't have, we are enrolling the teachers. Unfortunately, we are a teacher development organization. We train teachers and then the teachers come to your rooms to teach and we follow to see how they are doing the job. And we are not training them because they are new to the training, but they are new to e-learning, some of them. So we prepare them before they actually come to your classrooms. And that is why we might have delayed to get some subjects on board because we are still looking at who is the best to come to you. But I want to thank you for keeping with us. And those who can, please use the big blue button so that you save on data. Unfortunately for the Airtel people, we can only take lists to Airtel when we are sure who is studying. And those are the lists we are collecting every other day. So keep registering so that we know who is consistent. I want to thank Mr. Kaziva, Mr. Henry, and all the other teachers who have been on the call. Thank you. And for Emma and Lawrence, well done. Mr. Sairo, well done. We will catch up again tomorrow for entrepreneurship. Bye-bye. Over to you, Mr. Kaziva.
Thank you so much, Ronald. We can have a closing prayer. Someone had
Vivian.
Vivian, yes.
I don't know that she's still on.
Vivian.
Yeah, she's on.
Vivian, okay. I've seen her. Vivian, you can unmute.
Let's humble ourselves to a closing prayer. Almighty God, we thank you for the time. We thank you for each and everything that we've learned. We thank you for our teachers. We thank you for enabling them to to teach us, Lord Father. As we are going to end this meeting, Lord, may you please enable us to recall each and everything that they've taught us. May it not go down the drain, but may it still stay in us so that we may be able to excel in our examinations. We pray all this in the blessed name of Jesus Christ, our Lord. Amen.
Amen.
Thank you so much, Vivian, and thank you, everyone. Let's meet tomorrow. Bye-bye.